Yep, get the nods. Cool. So, yeah, it's 10 a.m. It's Friday morning, Surge 2013. My name is Tim Chadwick. This is my friend and colleague, Chris Baker. We work for Dyne, Dynamic Network Services, and we're here to talk about capacity and how when you don't understand what your capacity is, you have lots of problems, and that's a good opportunity to learn and improve. So let's get right into it. So we have a great problem. We have lots of great customers, a growing market, and everyone that we work with, they want performance. They want great value, they want scale. So this is something that gets us excited every day. But we have a bad problem, right? We didn't understand our system capacity sufficiently, and we're still improving. We're still getting better at this. And so when you don't understand it, you can get system failures and all kinds of surprises, and that's where you get volatile performance, poor customer experience, and not much sleep. So that was our task, improve this, and that requires some change. That requires some reflection. That requires stepping back and thinking about what it's going to take to get to that next level of scale. You got to think in orders of magnitude. So a great way to do that is to just learn from your failures and take a look at the system in a holistic and fresh perspective. And the goal is to make sure that your capacity is always greater than your sales, right? You always want to make sure whatever your inbound stream is, you're prepared to handle it. So like I was saying, get the best customer experience possible. Like that is the ultimate goal. Make sure that your customers are happy and you never have to disappoint them. IRs, we'll talk about those in a little bit. I'm sure, because this is Surge, everyone's got some amount of operations and DevOps thing going on, and so you probably have something like incident reports. So we want to get rid of those. And never turn away a customer, right? Not quite as bad as an IR. You could debate this, but it really sucks when you have to tell someone, you know what, we love working with you, but we're just not going to be able to handle what you want right now. So that get rid of all that, and then when you're done, go get some new suits. It'll be great. Right. So incident reports. At Dyne, we use IRs to track when there's a system failure that results in poor customer performance. We also have IRs when something just generic breaks and it's kind of like back end, but that's the primary purpose of IRs, is to learn from failures. And so on occasion, it's worth going through and looking at all of the IRs. And so depending on where your own organization is in its growth level, you can imagine that you maybe have like a few IRs. You might have tens, you might have thousands. I was talking with someone the other day, and they were saying how some places like large banks, like they have hundreds of thousands of Nagios alerts a week, and you can only imagine how to deal with that. So we went back and we looked at all of our IRs for 2013 up until about the end of August, right? So roughly think about how many days that is, and we have 258 total. So that's almost an incident a day, right? So that's it's kind of awkward, okay? But some of those are from like individual events, and they spawn multiple IRs, so it might not be quite that bad. But at Dyne, we have our flagship platform is the Dynect platform, and it has two primary products. It's DNS and Mail. And Chris and I, we're mostly focused with DNS. We occasionally will be working with the Mail team, and we're starting to have a more complete and holistic engineering organization. So we might be doing more of that. But today we're going to focus on DNS, and of course that means also like operationally specific IRs, things that are cross-platform or cross-product. And so to boil it down, we have 163 DNS operational incident reports. And so for the context of this conversation, I wanted to just break it out and make it kind of segmented, right? So when I say bugs, that's kind of like everything else that wasn't capacity. It's not purely just your classic kind of software bug. So just keep that in mind. But then capacity. These are three basic buckets: things that fall into the ops category, things that are really just attack vectors, things that are capacity but are not kind of like your classic, sort of customer use, and then simple, capacity problems that we just were not prepared to handle. So, like I said, the talk is focused on DNS, and we look at capacity in a couple of different perspectives, right? We have the logical, the physical, and the organization. So the logical, it's the expression of your business, right? It's your data model, it's all of your configuration variables, all the thresholds that you have everywhere, right? There's tens of thousands of these things. The physical is kind of like it's like the meat, it's like the horsepower, it's like the fun stuff, like if you're an ops guy, right? So it's all the bandwidth, CPU, IOPS, the disk, the media, how fast everything is going. And then, of course, we have the organizational. And so we'll get into that briefly, but that's something that I think we're less interested in today, but you can't forget about it because it's crucial. So let's treat that real quick, right? So understanding your organizational capacity is pretty important, right? What you build, your architecture, it's an expression of who you are. And so if it's going to fail, it's going to be because of some gap. It's going to be because of something that you didn't think of. And so I think it's important to ask yourself, what do I know? What do I not know is just as important, because it's really, knowing thyself is going to be the place where you figure out what you're going to be able to get done. So, and then, as an extension of that, the organization itself, right? So I'm sure we've all been through different experiences where you may have had an organization where there was like, the boss or like the CEO, and it was just straight business, and maybe you didn't understand technology so much, and so, it was harder to prioritize the right things, or maybe it was, totally engineering oriented, and so sometimes you had a hard time getting the right features out there because your product management roadmap wasn't as clear as it ought to have been. So finding that balance is pretty important. So don't forget about that, and I think it's a credit to Surge that we actually have like an entire track to treat that this year. There's been some great talks, so just wanted to cover that for our concerns of capacity. And let's take a moment and think about our tooling, right? So depending on where your organization is, like these are very familiar to you, and if they're not, make sure these are familiar to you. As you can see, we have quite the gamut. We have like a hodgepodge. Our system was grown very organically, and so it's not quite as like a holistic, sort of toolkit, but we're improving that. We're getting there, but thought we'd just go over this and just kind of paint the picture. I think one thing to take away from this in particular is that we use graphite a lot for everything. As an organization which was spawned from a very operational and network perspective, what you might consider like business intelligence or like classic reporting in other organizations is graphite for us, right? Everything goes into graphite, and that's pretty useful. But
before we jump away from this one, you'll notice that Munin is listed up there 3 times. Now, as you're growing, it's very easy to go out there and find a simple Munin plugin to solve a problem and surface some data. But Munin paired with RRD is kind of like having an imaginary friend when you're a little kid. It'll help you understand different facets of self very quickly and cheaply. But if you don't get rid of it, then you're the creepy guy talking to himself. And essentially, the feedback mechanism is weak. So being a guy who has a passionate love for data, anytime you put something into an RRD, a bunny dies.
Love it. Cool. So, yeah, exactly. Yeah. Right. So, what do we got to do? We need to step back and think about how we're going to have this new perspective on capacity, understand the system, and deliver better customer experience at scale. Right. So start with the business. Right. If you don't understand your business, you're not going to make it very far because you're going to prioritize the wrong things. So you have to understand that. Map those to your critical systems, and that sounds like implicit, right? That sounds redundant, right? You built this stuff. You should already know how it works, but when it's grown that way, sometimes you have to step back and take that fresh look, right? But you can't always get everything you want, right? Like if it was up to us, just boom, all the data just coming and it's all aggregated and you can understand it with a glance. But there's other things going on, there's other priorities, and you have to find a balance. And then communicate it, right? Find a way to put it to a place where the entire business can look at that and appreciate what the core metrics are, right? Everyone can have an agreement, be on the same page, and then work together with the right priorities. And one thing that we found is that when you have a debt of data visibility, it's hard to get, like our implementation group, they're signing on lots of customers, but sometimes we're getting questions like very ad hoc, right? Like, oh, can we handle this sort of customer? And we would have to, yeah, we can do that, right? But that doesn't scale very well. That's not very efficient. So this last bullet just speaks to the fact that we improved our processes before we moved on. We worked with our implementation group to give them a set of rules, a set of like questions to ask. And so this is just part of like the customer vetting process. So improving our process was a function of this as well. So that's it's a start. Right now we have a Graphite dashboard, and we have a narrative to go with it, right? So It's not everything that we want, but it's a start, and it's moving us along, and it's setting the right priorities. So this is the start to taking a look at our capacity. And so we identified a few key business metrics, right? Anyone that's familiar with DNS can appreciate queries per second, zones, and then the API, right? Our API is our primary interface for our customers to update their zones and do all sorts of different things. And so particularly at scale, this is really the only mechanism. We have lots of customers that all of their interactions are back-end processes, so that's pretty critical.
And before we leave the idea of weak visibility, there's a point of communications where engineers start to try to understand things. And my default mode is then to go into a lab environment and basically create a whole collection of graphs which express potentially what this thing could do. And go into deep detail, caveating things with collections of asterisks, and then over time improving that understanding. Well, it turns out not many people want to read that. I can't really blame them because it's pretty, in a sense, it's navel gazing, but there's a goal there. So until we have a point where we can point our implementation team to a picture and say, this is the line at which we can continue to sell, and we are here on this line, I haven't really done my job properly. Because they're still trying to pull information from me to get us more money. So I am a bottleneck in our ability to get more money. And similarly to that, without that graph, it's hard to explain to people why we can't do something and how we need to make investments to move where that line currently is. So we'll get into that a little bit more, but that's kind of the business problem we're trying to solve with a lot of this data that I continually try to justify myself when I'm saying buy more, bigger, expensive machines with faster disks and give me everything you can off the wire. Yeah, so use that explanation if you're looking for a massive CapEx on metrics collection.
Yeah, and so there's a little bit more to it than just these three things, and so we'll get into that a little bit. But now time for the true catharsis, which is Surge, right? Let's get into the incident reports themselves. Let's look at some examples which correlate to those key business metrics and just appreciate the path, the journey that we've taken.
So the first thing we need to do here is kind of set the stage for how we're treating our problems. So the title of the talk is going from a metric and data debt. So the most simple way for our business to understand what we're currently doing is to look at a net volume of QPS across the platform. And that's what this picture is. So this is if you take everything around the world, sum it per second, it kind of looks like this. Now you'll notice some odd dips in there due to data collection failures and other things. But essentially, you should look at us and be like, hey, that's a simple linear model. What do you guys really do? So, to kind of justify that and, express the cost of this level of summary and what looking at the business from this perspective does, we need to peel back another layer of the onion. Essentially, that graph causes problems. Because if you take the capacity of every single machine we have at the edge to resolve queries, and you put it into one amalgamous block and assume that is evenly distributed across the world, things are going to break. So you can go to the next level. Now this allows us to express one layer deeper of data. So this gives you some understanding of the wave-like pattern that we're actually seeing on the edge, as well as some understanding for those anomalies and how frequently they occur. So towards the end there, you'll see some really high spun anomalies, and we need to be able to absorb those. Those might be attacks, they might be customer surges in traffic, and we need to be able to serve and resolve all those queries, or else our customers aren't having a proper experience. So even using something like this, it's another level of summarization that kind of hides some of our deeper problems. Now this is the picture I like to use because it's kind of like a weird heart pattern that ops gets. Now, so if you think about it this way, this is the diurnal pattern of everybody on the world using the internet. So on that left hump, that's Sunday, followed by Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. This is a cool pattern, but if you look at it, these lines represent different regions. So the distribution of traffic across regions is not very non-standard. So if we start looking at those higher level summaries, what we're missing from a capacity perspective is, wow, it kind of looks like 6 or 7 places are doing most of the work, and the rest of them are kind of bumming along. So that leads to the idea that we need to create an equation for capacity. Now, equations have power because they represent the fact that I'm willing to say I understand something, and people are afraid of math. So if you can walk in and say, this is the equation, we're going to make decisions based on this, and you know why, and then roll through all those graphs that you made and force them to read them, because they're actually like the proof of data collection for your capacity model, one step closer to winning. So we're going to go over this equation and kind of how it came to be through different data collection methods. But for right now, that's just kind of like setting the stage for how we're starting to think, or how we've started to think about capacity and model it. But wait, there's more.
Right, so Chris just set up like the QPS question, right? Like what's the equation of the business at that fundamental level? But there's a little bit more to it, right? So after we've served a response, right, and the DNS aspect is complete, there's also downstream, right? We collect all of these queries and we want to inspect them for a variety of purposes, right? We want to have better DNS monitoring, we want to do billing, all of these things. And so sometimes you can have a customer profile where maybe they don't have a lot of QPS, maybe they aren't like a capacity threat, but there's something about their model which is like a little bit sneaky, right? And so low zones, not a lot of breadth, not too many records, low QPS, but then wildcards, right? So anyone that's familiar with DNS wildcards can appreciate how that can quickly lead to some complications in your capacity. So when you track all of the FQDNs for all of the QPS that is happening, that's a lot to count, right? So just add them up, right? But with the wildcards, that's like an open-ended capacity problem just sitting there embedded in someone's customer model, right? So for every activity that happens on their business model, which adds another unique FQDN, right? You have to observe that, process that, and then keep it going. And so we had one particular customer. How did we refer to this?
A large social network micro-blogging platform.
Right, so there may be a particular customer that may be using wildcards of this fashion, and you might be able to appreciate how a normal customer might have maybe 10, couple thousand wildcard entries. So we're talking the hundreds of millions and the billions on a daily basis here, and you can see the tragedy that happened to this one server. So we have a distribution of database servers which are eating up IOPS with all this activity, and you can see particularly around like February, it was really getting bad. So this is an aggregate Munin graph. So on a daily basis, on a weekly basis, it's actually it was much worse than that. So we were really getting some poor performance. So anyone that is a current customer of ours, sometimes you want to log in and look at your daily QPS traffic, and so it's our goal to keep that as up to date as possible, right? And so that's the job of the QPS processing system. And so when we were getting bad response times on this system due to so many FQDNs trying to be tracked, right? That's bad customer experience, and so that's not good, right? So every time something like that happens, like I have to go post like a status report, and the IRs come out and it's we didn't understand capacity, right? We had a hole in our design there. But right, so we were able to handle it, right? This IR got closed, we fixed it, but right, that sucked. Right? The customers experienced something that it was less than ideal, and then more than that, it took time away from a few of us, working on better things to solve this, right? And so this is reactive and this is manual work, and those are expensive things. So that's bad, right? That's no good. And so that's a sneaky aspect of the QPS problem.
So in proper Bowinkle fashion, our transition slide has two titles. This one especially goes out to Mr. Pete Cheslock, DevOps thought leader. So this is kind of the reaction, like as the world goes on and the incidents are going on and pages are going off, I get this like creepy smile on my face, because that is like this beautiful data point that we can go in there and then kind of make a really cool picture of. And that's kind of what this next set of slides is about. It's about making pictures of your problems so that when somebody asks you what happened there, you can say, oh, well, yeah, well, this picture has it. This simple set of lines can try to explain how we messed up and what kind of caused us to realize that we'd messed up. So the first scenario that we're going to cover here is thinking about failover. So my background wasn't directly in internet architecture. So when I started looking at how we'd think about failover from a capacity model standpoint, I was like, oh, how does Amazon do that? So they have US East, they have US West, and they have these regions. So what I'll do is I'll go and I'll categorize our data centers into these regions. And then when there's a failover, I can try to figure out how that'll work, like how the traffic's going to roll between sites. Well, it turns out that the internet doesn't care about state boundaries and all those fun things. It only cares about fiber lines and your transit provider's preferences. So we had an incident where all of a sudden we lost power in a data center. Awesome, right? Like, this is the coolest thing ever, because now I can go back and I can look at actually where all that QPS went. So it turns out this idea, okay, just to describe the sizings a bit off here. So each of these lines represents an entire site's QPS, and you'll notice one of them all of a sudden drops off to the bottom, Wile E. Coyote style, and kind of like hits the floor until we get power back on the site. Now, what those other lines are representing is the redistribution of those queries per second across other data centers. The most beautiful part of it is, if I were to go with this regional model, assuming that the Midwest took care of the Midwest, it would be horribly flawed. Because realistically, the Midwest, when something fails there, it goes east, it goes west, and it goes to the Midwest. So thinking about regions from any kind of geographic perspective all of a sudden starts to really hurt, and surfaces, just like your own lack of understanding of how these things are going on behind the scenes. So what I learned from this incident, geography doesn't matter, and you need to learn a lot more about how transit works. So that kind of covers failover, but also into this bucket we can kind of start to address the topic of maintenance. So we all have servers that have problems. You buy a whole bunch of machines at the same time. Turns out their disks all have issues and they start to fail, and you need to have enough of them in a site that you can take those offline and fix them and still maintain the volume of traffic which the site is expected to do. So in there you have this cool kind of sliding bar where you can say, I want to be able to operate with half the number of machines, a quarter of the machines, one machine, and you can kind of work that into an array. So that way when you're talking to management about how you're sizing different data centers, you can say, well, this is the current risk that we're priced at. This is the risk that we've agreed we're going to pay for. But if you'd like that next level of stability, this is what it's going to cost. And explain to them directly how we're allocating that QPS for a maintenance scenario. And by separating it from failover, you can say that, I now roughly understand what'll happen if there's a failover and we have maintenance going on in a site which is going to receive some of that additional traffic. Now, the next part, we're going to talk a little bit about attacks. Now, from our customer's perspective, attacks are horrible because it means their services are going down. But if you really look at it and think about it, it's kind of cool for you, right? Like, you're now important enough that somebody has decided they want to take you off the internet. That's kind of, it's like having the paparazzi. Like, yeah, they're evil, but it's like this feedback loop that I've done something right. So when attacks roll in, it's important for us to try to categorize those, qualify those, and learn as much as we can, because they're never going to stop. And the more we can collect and understand and build models of, the better we're going to be able to react to them. So an attack rolls in. Now, what are we looking at here? So each of these lines represents a global region. I know a few minutes ago I just said that those are kind of useless. But in this case, they're an interesting metric, because this is kind of what differentiates a denial of service from a distributed denial of service. So in this case, each of those lines represents the East Coast, the West Coast, the Midwest, Asia Pacific, and Europe. And in this case, we saw traffic bumps in all of those except for the East Coast. So when we're thinking about how this attack came in, we say, okay, well, now I know one thing about it, and I've kind of grouped together the potential mitigations I can use to control it. So, putting the D in DDoS. The attacker's ability to actually spread traffic across multiple sites controls our ability to mitigate. Now, if we go one level deeper from geo-region to specific sites within that region, we then get an even better understanding of how well distributed this attack is. So is there only one site in each of these regions that's getting hit? Or is it blanketed across the sites in each region as well as all of the regions? Now, the reason classification is important is it controls our ability to react. So classify. But realistically, there's a whole lot of data points we can start to pull out of this. And this puts a burden on operations initially, because now we're kind of forcing them in an attack to think more about taking notes, which is a rude thing for me to do and very selfish, but in the end it'll be good for all of us, because what we're trying to do is we're trying to put together enough data that when we evaluate these things, we have almost an expert system level of understanding. So how many sites were impacted? This is like the DDoS versus denial of service, or other category, because those are fun too. What was the magnitude of the attack? So this falls into an area of both packets per second as well as bandwidth usage, because through splitting out those variables, we now understand a bit more about the attacker's vector. the protocol, in or out of protocol. So out-of-protocol attacks are very nice. In-protocol attacks are kind of a pain because our ability to mitigate it and still provide full customer service without impacting anyone is lessened slightly. What is the customer impact? Now this one is really important because what this kind of gauges is how well we did from our customer's perspective. So when we're going across these metrics, ideally we'll be able to go through and say, well, we used this resolution methodology, but there was more of a customer impact due to the methodology that we used. And over time, kind of get a gradient understanding of those and say, you know, we prefer to use this method because there's literally going to be no customer impact, but it takes longer, or we can use this method, which has a customer impact and has a shorter mitigation time. Now, these are the important ones for when you're communicating back how things are working. Because what management is concerned about is what is your mean time to understand that an attack has happened? How long is it taking you to understand what exactly is going on? And then how long did it take for you to fix it? So when you're starting to think about the investments being made in systems which help you identify and stop attacks, these are the metrics which you're going to be able to drive home how investment should work. So when you're proposing a purchase, you can say, oh, well, you know, we're assuming that this is going to cut our time to identify by half, by a quarter, and then kind of put it in clear terms of achievable metrics that people can appreciate and track over time. So this is simply put. So that kind of covers the area of attack soak. But before leaving there, attack soak is interesting in that it's this wide range, and basically you're choosing in the range what you want to pay for, similar to what we were talking about with maintenance and the number of machines to have in a site. So this is where it's also important to kind of survey the field and see what's going on with other people. So when the great the Cloudflare spam host DDoS went down, and it was like 300 gigabits per second, you now have like this really awesome metric to put at the top of your risk index and say, you know, you could pay to mitigate this, but it costs this much money. And then kind of like work your way down on where you're willing to invest and what types of attacks you're seeing and get a better understanding of what's going on in the field. So let's go through this again because anomalous traffic patterns are important on the internet. So this is a disgusting graph, I know, I apologize in advance. But as you're looking along, the diurnal pattern is pretty sane, and then we have this incident here, where all of a sudden, net traffic is spiking off the charts. So we start to dig in and look at this awesome Crayola-like drawing of scribbling across a region. So we now know the attack is distributed across multiple sites. Now to spare you, we'll go to a pretty, more calming, less Crayola perspective. So what we're seeing here is all of a sudden there's this massive spike. So operations is getting paged. We know there's an incident going on, and the question is, what are we going to do? So anomalous traffic is a signal that we need to understand exactly what's going on. And then when digging into the traffic, we understand, oh, okay, well, this is related to a single customer. So chances are, this really looks like an attack, guys. We should do something. But this is where client services comes in. Because you don't want to go in and just stop traffic to somebody's website because you think something's going on. So you reach out to the customer, and they kind of get an understanding of what it is, and they're like, no, let that through. That's good. But from all the other indicators that we have, this is something that we don't want to let through. So when we're putting together our matrix of understanding how to respond to incidents, having these in there as other indicators of control situations is really important. So what do we learn? Anomalies happen on the internet, and there's a lot of events that go on with our customers that are going to directly impact us. So it was funny, I was having a conversation the other night, and somebody started talking about the impact that the World Cup was going to have. And all I could think was, that's going to look like a really awesome DDoS. Because all of a sudden, the internet usage pattern is going to come highly off-peak, and it's going to come in great force. So the more we start to think about these outside incidents and how they impact our customers, the better we can start to categorize, prioritize, and build our networks to facilitate for this. So for now, we're just going to cross out the attack and call it soak, because realistically, we want to soak other events as well as attacks and not always assume that we can shed the traffic quickly. And that's important from a duration perspective, because you never know how long that surge is going to go on, especially in the case of something like the World Cup. So we're going to talk about the zone metric.
Sure. So, going back to our top three, we covered QPS in a lot of detail there. I think people have a better sense of, the sorts of metrics and the sorts of methodology we have for managing that. But let's not forget about the actual data model, right? It's a in some ways, a much more simple thing to the point where we don't have to think about it as often, but it's pretty fundamental, right? Like how many zones records can we fit in memory at any one time? And so as Chris added here, the retail analogy is it's our shelf space, right? Literally, what is our inventory capacity? And so this doesn't manifest itself so much as like an IR or like a sudden burst sort of problem. This is a different sort of event where this is the other problem where we have to talk. People want our services and we have to say we're sorry, we can't do that right now. And so that's, like I said, like that's not quite an IR, but that's something that's also disappointing. So as much as we try, we're just adding memory and we're trying to make sure that that shelf space is as large as can be. But again, this is something that doesn't manifest itself as an IR, and so it's a slightly different kind of problem, but it's equally as important. And so this is the goal, right? We want to avoid that sort of problem, and so this is a key metric to keep an eye on.
And so before we leave there real quickly, this is a different set of feedback loops. So this isn't something that a system can tell us. This isn't something that we can extrapolate ourselves as engineers living in boxes. This comes from having a really healthy and clean channel of communication to sales. So we understand who sales is targeting, what their acquisition rate is, what the timelines look like for bringing those big customers on, so that this never happens. And if you think about all the things that would need to happen if you brought on somebody who is twice your current size, from hardware deployments to data center upgrades to working with smart hands, there's like a large chain of dependent events that then get kicked off. So this is an awesome feedback loop to think about because it's a human one, and all it really takes is going to talk to your sales team to see right now what they're doing in terms of metric collection and how they can get that to you and how you can get it into your models. Yeah,
and going back briefly to the communication and the process aspect, you can't scale if this is a manual task, if this is a person-to-person communication. Like this boils down to us taking our graphite dashboard and then making something which is more rich but actually has those dotted capacity lines, right? And so instead of people coming up and saying, hey, can we handle this, can we do this? We'll just say, I don't know, look at the graph, right? You tell me, I haven't looked today, right? And so that's a much more efficient way that improves our process quite a bit, and it disseminates more information across the organization.
So we've just gone on and on about edge resolution of queries. Now, there's another important vector to all of this, which is our ingress of change from customers. And one of the beautiful things about working with the type of customers that are here at Surge is chances are you have a pretty cutting edge use case. And that cutting edge use case is going to push us to be that much better because we need to deal with what you're trying to do. Or in other words, you're more than willing to help us stress test our platform in production, and we're more than willing to let you help us improve.
Voluntarily and involuntarily.
Yes.
Anytime.
So the first one we're going to walk through here is a classic, knowledge transfer kind of issue. So everybody's seen one of these before, right? So you have this rate which you have no control of whatsoever, realistically, unless you throw some kind of load distribution mechanism in here. You have a number of customers making a number of requests, right? And that all manifests itself as work. Now on your side, you happen to have a number of workers and a number of things they can do per second. So as you imagine, if that rate exceeds the rate which you can get work done, bad things happen. Yep. Now, right here, we have a small bump in API request volume. It turns out the cost of processing each of these transactions is higher than normal. So what happens to those workers' rates of throughput? Well, they drop. And how does that drop manifest? That's a massive spike in the average request runtime. So in thinking about the future world of real-time user metrics, this is how our customer experienced our platform. All of a sudden, everything was running smoothly, and all of a sudden they felt a large delay based on this exhaustion of resource. So what does this tell us? Well, we need a better feedback mechanism to control and understand our ingress, and we also need better understanding of average runtimes, even customer level runtimes. Because what this tells us is even if this gets slow, we should probably reach out and let them know that we might have hurt their business in the sense that things went slower for a period of time that they might have adjusted for. And it's always better to go to somebody and say, I'm sorry, than wait for them to come to you and say, why did you do that?
Yeah, that's an example of where who's going to have the IR first, us or our operationally scaled customers who have tight API integrations, right? They have their own Nagios alerts, right? When calls are taking a certain amount of time, that's a threat to their business. And so, working together to make sure that we're going to take care of it is pretty important.
So last year when I came here, everybody had like really awesome like disaster porn slides. So I figured I'd go in and I'd grab a few, just like relative spikes to throw them in there to show how deviant from the norm this activity really is on a rough scale. So it's just a quick shot under the hood. So the next case is really interesting because what we just talked about from an API exhaustion perspective is something like you'd expect. Our ability to maintain throughput was an issue. Now, sometimes there's other collections of changes which are going to manifest themselves in different ways. So the time scale on the x-axis here is much larger in this case. So a bunch of this incident was honestly my fault. This right here was me testing in production a use case which a customer came to us and asked if we'd be able to do. I ran over to our implementation guys and I was like, hey, just give me a day. I'm going to do this in prod. So I did it in prod, and people's alerts were kind of down because I told them that I was testing in production. Well, you'll notice a significant dip here, and then another large anomalous pattern emerges.
Yeah, Chris was being a good capacity doobie, and then it was a red herring for an actual problem that was going on.
Yes. Yeah. And so this was me. I apologize, customers. And then this was the other thing, right? So what is this other thing? Well, it turns out that we'd recently made some changes to the platform where previously this other thing couldn't have happened. But now it could because we removed one capacity bottleneck and the next one started to show its cards. So a little more inside.
Yeah. So we had a customer who they were actually a demo customer at the time, and their API activity had gone runaway, and they were basically gone for the weekend. And so just lots of constant activity as much as possible. And so you can see where this is an expression really of CPU time slicing, right? In the past, as Chris mentioned, we never would have gotten to this point because the database contention was at the media, right? It was IOPS, right? So you wouldn't get this problem. But once that was shifted, someone that had a runaway process just constantly requesting things, they were able to get access to the CPU and just go nuts with it, right? So juxtapose what Chris was doing, which was an actual correct load test. We didn't see this as much, but so this is where the real threat started to manifest later in the weekend.
So this really happened. So that's available disk space on our master API database. So in the famous words of Allen Iverson, disk space, disk space. We're not talking about IOPS. We're talking about disk space. This stuff is supposed to be so cheap and ubiquitous now. But it turns out when somebody has a runaway transaction and that transaction has multiple steps and then steps start failing, failure is really fast, really fast. So that ramp just kind of shoots right up, and the controls in there, the other steps which would take time to process, just manifest themselves in massive failure patterns, which apparently fill disk pretty quickly. Looks over at clock. Okay.
Yeah.
So now we'll do a little back and forth on the capacity lessons. Know thyself. If you really know yourself, then you can kind of just like walk away here. But realistically, if you come into a platform that is already in motion, there's going to be skeletons and weird sysconfigs that people forgot they set places, and they'll manifest themselves eventually. So try to get a good understanding of them. Understanding your business is a function of knowing your customers and your customers' interaction patterns. So knowing that attack or what appears to be attack may not be an attack, or looking at a volume of activity that's related to a customer's API failover scenario or something of that nature, just having an understanding of what might come based on how people are using your services.
Yeah, the only thing more important than knowing yourself is knowing every aspect of your customers, and they're always going to be teaching you new things because they're on their own innovation curve. So you got to focus there, right? And then get all the data as much as you can. You never want to sacrifice telemetry. That's a key. And anyone that's seen any of Theo's talks, that's a core fundamental. Worry about the aggregation later, but if at the lowest levels, if you start trying to aggregate the data, you're going to lose things, and that's going to lead to unexpected problems because you're going to pass over information thinking that there's no problem there, and there might be because you've lost some amount of granularity there. And once you have a shared understanding for what's going on, communicate it broadly, right? This gets back to knowing yourself and knowing your organization. If Chris and I know this, that's cool, but it doesn't really help the organization. We need to proliferate this. We need to make sure that everyone is on the same page so that we can make the right priorities and set the right projects up.
Most importantly, learn from your mistakes. If there's one thing I really want to drive home to people is every time you have an incident, make a picture. And have somebody invest the time to make a picture of that incident. Because then you can always go back and flip through all the awesome pictures of things you've overcome and feel a lot better about yourself. Or you can do the reverse and look through all the pictures of all the ways you failed and how you stink. Right? So they're both good feedback mechanisms because they help you understand and they force you to think a lot more about it. And what they become is a function which drives the need for more data. So in the end, my goal is always to try to justify more data. Whether it's right or wrong, I will be very open and honest about that. And the more you start to make these pictures, and people ask questions about the pictures, well, how do you know this? How do you know this other piece? Well, I'd be able to tell you a lot better story if we had more data. And that's it's a slow driver. So then when you're going through your list of pictures of all the bad things that happened, and you continuously come up on a theme of, oh, we're missing this, we're missing this, we're missing this, this wasn't granular enough, this wasn't surfaced well enough. And the surfacing well enough is as Tim mentioned, just as big, if not a bigger problem, because as our company has grown massively over time, our ability to communicate and make sure that all the information gets pushed to the right people, it doesn't scale very well because we have a finite amount of time. So we can't work on a push mechanism anymore. We need to deploy like a pull mechanism so that we can publish things and people can look at those things. And these incident reports and these write-up of incident reports are the perfect manifestation for that.
Yep. And lastly, sharing. I mean, everything that Chris just said about his just innate desire to make pictures and describe things, right? That's the same thing. Share it, right? And so for our own internal processes and trying to improve our business for our customers, we're doing our own piece of sharing there, but don't stop there, right? That's why Surge is great, is because at some point we do go through on occasion and kind of look at the IRs in a more comprehensive fashion, but because we're oh, we can do this capacity talk, we can think about this, there might be something there. Oh, now we have to go through whatever, almost 300 IRs and really think about that sort of thing, right? And so hopefully that can be something that other folks can learn from, and if not, just let us know and we'll think about something else, but we'll do it together, right? Cool. So that's pretty much the extent of our talk, and so we timed it roughly so that we'd have a few minutes for questions and a little bit more conversation. But if folks don't have a lot on their minds, then we have one other thing that we could throw at you. So we thought we'd open it up to start, see if folks had any particular questions. How's it going? Sure. So, this is a small room, but the question was, what's our methodology for categorizing the IRs? And so, I'm sure a lot of folks are familiar with JIRA, right? The JIRA monster, the Atlassian suite. So that's an expression of that is where we keep our IRs. And so it's mostly manual, but we do a decent job of annotating them. And so basically dumping it and then slicing and dicing, right? It's kind of your classic pivot table problem. But I think to the point of your question, when I was doing this, it gave me some, it made me think about other ways that we could annotate, things that I could add to this so that next time I go do it, it's not quite as manual. Yeah.
And one thing we kind of learned from this is the information architecture, which is important to categorizing these things, because so Jira does a really good job of putting things in very generic buckets. So like the DNS versus email, and even one step down from there. But to get to the level where it starts to become really useful, chances are things fall in either to multiple categories, or you want to create new categories to take care of other events. So at Tim's first pass in this, to his credit, what he did was he went through and he granularly identified the system resource which was exhausted, which I wouldn't have thought to do initially. So the more we do this, the more complete of an information architecture and categorization scheme we're going to get. And I think that's spot on. So that'd be an awesome plugin for Jira now that I think about it, for aggregating that metadata so that we don't have to do it later.
Any other thoughts, questions? Mike?
So capacity planning has a lot of different thoughts behind it in terms of how many servers do you have, how much disk do you have, Miley Cyrus is on the VMAs, so we're gonna have a CPU, or is it more we should just buy more goddamn discs? Like, I'm curious about if there's been an analysis of what's going on with those and lessons learned that you can share with all of us.
Absolutely. And so one thing that when we were kind of running through this, I wanted to take a minute and talk about how we're not treating the design here, right? We're just talking, like, we're stipulating that this is a system, and then we're dealing with it in a capacity perspective. And so to the point of your question, it's a little bit of both, I think, right? Because some layers, some aspects of the architecture are built so that they're a lot more of that, like, kind of plastic parallel, horizontal, sort of implementation. So it's in most cases a lot more of a simple sort of thing. Like Chris can look at how our QPS is doing. Take that formula and say, okay, if these events happen, this is what capacity means in Europe. Therefore, if we don't want to have bad things like drop packets and other sorts of weird anycast issues, we're going to need this many servers. It's pretty simple. But then we have other problems where we're looking at like we have an API database, right? And so that's your classic sort of master-slave MySQL architecture. So you can't just add more boxes to that sort of thing, right? And so in that case, we need to think about it in a kind of like a little bit more tactical sort of case. So I think the answer is it boils down to the different aspects of the architecture, and then looking at the different formulas and doing the best we can, right? In some cases, we can just blast at it. In other cases, we need to rethink the architecture, frankly. Yeah.
And I think one of the cases that we pulled out here, because now that I think about it, it would have been interesting to include, but doesn't have as fun of a story, is just the average change in query log size compressed, which has been the bane of Tim's existence on a few occasions. And I think it just kind of hurts him to bring it up in public and have to remember that.
Yep.
So do we have,
That's a good question.
how are we doing for time?
Yep.
Oh, so
Any other questions? Cool. Oh, yes. Is there one? We have lots of thoughts on that, yeah.
Yes. So a few days before we came here, the folks at Twitter put out an amazing post on observability. So when you read through that post on observability, as a data guy, all you do is get more and more jealous. So somebody has taken a stab at this and made something phenomenal. Now, I'll also give some serious credit to the folks over at Box for Status Wolf, which is like the new UI which sits on top of OpenTSDB. A lot of our problem comes from granularity and growth of importance of granularity over time. So it's when you're initially designing something and your user base isn't as demanding, you don't think you need to look at things as finely as you do now when all of a sudden you've experienced massive growth and customers have greater concerns. So from a monitoring perspective, I'd say early and often monitor at the most granular unit and figure out how to deal with it. And anybody who tells you it's too hard or too expensive, just tell them in like 6 or 7 months after your hockey stick starts to grow that you are going to be a hero for demanding and dying on the hill for that spend. And I mean that wholeheartedly, because every time you abstract data, something bad happens. So I still have this serious fight inside myself that we talk about QPS, right? Because on the internet, even a second is an eternity. And what's the chance you're going to get that nice smooth curve? You're not. The internet is a violent and turbulent place, and the number of packets coming in per microsecond itself is extremely violent. So you even want to get smaller than that, and then you start thinking about, well, how should I be spending on keeping track of time? And what's the piece of equipment cost which can properly synchronize time across all these metrics? And the more and more you go down the rabbit hole, the more and more you can justify the need for this information. Maybe not all the time. Maybe occasionally at a certain interval you're taking packet samples and you're looking at how violent that is and why and kind of what is manifesting that violence. So one of the fun things that we have happen is there's this shelf of queries across the world, after people go to bed. And when I started here, I was like, what is that weird shelf of queries? What decides it's going to do work then? Are a whole bunch of people purging caches? So then you have all these recursives rolling in because they can get a new fresh update in. And the more you start to collect super granular data, the more you can actually model out exactly what is going on there. And you can identify, that guy doesn't respect TTLs. you know? And that's good for your customer to know too, because now you have some insight that drives them and gives them understanding as to, oh, well that's what happened with my QPS that day. That person refused to respect a TTL and they cost me money. And now on the even more fun side of that, in the new world of the zero TTL, what's more important than understanding how that impacts our customers? Like a true zero TTL.
Yeah, and I'll add to that I think, so I've gone through a series of different businesses where, they're on different growth paths, and that, that also means multi-billion-dollar companies, massive manufacturing operations, that sort of thing. And I think, in my experience, it's always best to get it right early, but that doesn't mean you have to get it all right. So there's a balance. In other words, like when you're starting off and you're just trying to get your features right, you need to make sure you have some amount of visibility, but don't sacrifice the business for making sure that you have telemetry across every different system metric across the platform, right? You got to find a balance. And so I think as you grow, it's important to look back at that organizational balance. Like are we tech heavy? Are we business heavy? Or is there some other dynamic there? So that you know when it's time to say, okay, we need to take a break for 1 quarter and just address the platform in terms of our operational sustainability. So I think that taking on Chris's tactical thoughts, that's where I would translate it into the business is find a balance, but start early and just be honest with yourself. Say, hey, you know what, we're not going to lose the granularity here, but we're not going to address all of it until maybe like next year or something like that.
And we can go back to know thyself for a moment. So I come from working in finance where money doesn't really matter and you can spend like crap tons on it, on getting like super exact stuff, because in the end if a regulator comes and you don't have that, you're in a lot of trouble. So moving to a different world without those caveats, it's very different. So I always have to remind myself that it may not be reasonable to spend millions and millions of dollars trying to literally capture every packet that crosses every part of the network all the time and collate them. So yeah, it's a know thyself problem, and then also know thy value you can offer when somebody asks you why you spent all that money.
That's a good question. Any other thoughts? What you got, Ray?
It wasn't obvious whether or not you try to do any correlation between one query to the next in terms of modeling, query behavior, or anything like that.
Yeah, could you repeat the question, like one break to the next? You mean like one incident?
Yeah.
Yeah.
Well, not one incident to the next, but one query to the next. Like, if there's correlated information between one query to the next, coming from a specific IP address or anything, do you try to do any?
Oh, sure. So I think the question was, put it in my own words, what sort of analysis do you do on the traffic patterns in order to understand something which might be good or something bad? And so particularly in an attack scenario, that's all we're doing, right? We're inspecting, the PCAPs are flying and we're looking at, what's the nature of this attack, where is it coming from, and kind of where is it going, right? Yeah, but we didn't really go into that, in depth, right? We didn't go into that correlation. And then I guess we do it in other ways, kind of like that downstream processing in order to understand some things. I don't know, you have any thoughts on that?
Yeah, so luckily for right now, I'd say about 20%, that's a BS statistic. I just said 20% without really knowing. There's a large collection of data on the internet that you can find which describes the packet structure made by certain types of botnets. And some of these are really good, other of these are awful. Now, the first step in automated detection would be like taking those PCAPs that people have collected from sandboxing this malware and then putting them into a mechanism which can compare them to what's coming in at that time. We haven't automated that yet, but it's one of those things like in the back of my mind where like on the weekends I do a lot of malware analysis, so I just sit there and like, oh man, it'd be so cool if we slurped all this up and we had this like readily available to go. But it's a phenomenal question, because whenever we're collecting data, I always justify it that in the end we can build an expert system to do this extremely well. And a big part of that is understanding the chains and relationships of queries. And the other thing that you can kind of dig into there is, maybe for your customers, you can also provide back to them an interaction pattern that your customers' customers have with them. So yeah, there's a lot of awesome work and analysis to be done there. And I think we have an idea for another talk.
Yeah. Yeah, I think your question points out that we do that sort of thing, but it's too manual, right? Like, so our story for capacity is getting better. We have prioritized the right initiatives, but we're just not there yet. You know, it's not all programmatic and automatic.
You're not doing any complex event processing or
Not sufficiently. Yep. No. Soon. It's a good question. Any others? Cool. All right. So should we talk about the octothorpe real quick?
Sure.
Right. So all right. So I was driving into work and I had this like thing come to me, and I was like, oh, this is what we should do, because everyone always closes with like, oh, we're hiring, right? And so my thought was we were going to project this concept, this like personification of the capacity monster. And the way that we're going to add a metric, a datum to the capacity problem is to ask people, like when you're in your systems and oh, there's a capacity problem, right? Use the Twitter thing, pound octothorpe. And so what's the octothorpe? For anyone that knows what an octothorpe is, this is kind of like an ironic, redundant thing, and I'll let people look it up later, but we're going to hijack this. And what the octothorpe is, my thought was like Cthulhu's like drunk uncle, like who really just hates IT and like infrastructure systems, right? And so he just attacks, and he comes in, he's gonna get you, and he's wearing like a shirt, and it's got like Theo's book, like scalable internet architecture is like crossed out, like right? But like we didn't have time to make that picture, right? So the idea is that like it's something like this, and so like if you want to come help us fight the octothorpe monster, then like come work with us at Dyn, and like me and Chris will we're like in like shining armor, standing on top of like a Tyrannosaurus Rex, like taking this thing on. But we didn't have time for the picture, so if you guys come across your own capacity problems, tweet it up, and then we'll be able to have a little bit more information next year, seeing how many times people came across this sort of thing. Yeah, that's it though. Thank you.
Thank you very much.